Have you ever met someone who can hear a car horn, or a bird chirping, or just a random note on a piano, and boom, they can name the exact pitch instantly? It really does feel kind of like a musical superpower. So, how is that even possible? I mean, really, where does this incredible, almost magical ability come from? Well, let's dive in and break it down. Okay, so this rare skill is officially called absolute pitch, but pretty much all of us know it as perfect pitch. It's the ability to process the pitch of a sound, its frequency, without needing to compare it to anything else. No reference point needed.
Now, to really get what's going on, we've got to compare it to what most musicians have, which is relative pitch. With relative pitch, you can identify a note, sure, but you need to hear another note first to figure out the distance between them. But someone with absolute pitch? Nope. They hear a G sharp, and their brain just knows it's a G sharp. It's just like how you look at a fire truck and your brain says, that's red. There's no comparison involved.
So this leads us to the big question. Are people born with this skill, or is it something they learn? It's the classic nature versus nurture debate. And with perfect pitch, the answer seems to be a really fascinating mix of both. So the case for nature is actually pretty strong. For starters, perfect pitch definitely runs in families. If you've got it, there's a much, much higher chance your siblings will too. In fact, some twin studies have estimated that the heritability of this could be as high as 80%. That points to a really powerful genetic link.
And it seems this genetic link actually shows up physically in the brain. Brain scans have found that people with perfect pitch often have a noticeable difference, a bigger asymmetry in a part of the brain that's crucial for processing sound in language. It's almost like they're born with a kind of pre-wiring that just makes it easier to pick up the skill.
But, genes are not the whole story. Not even close. The nurture side of this is just as important. The vast majority of people with perfect pitch started musical training at a really young age. We're talking usually before they were 6 years old. This points to what's called a critical period, which is this narrow window in childhood when the brain is super flexible and just ready to soak up these kinds of associations. And it seems the type of training really matters too. Methods that constantly hammer home the names of specific pitches are way more effective.
Okay, but the story of nature and nurture gets even more interesting when we throw a totally surprising clue into the mix: language.
So get this. Researchers found this amazing correlation. People who speak tonal languages, like Mandarin or Cantonese or Vietnamese, are way, way more likely to have perfect pitch than people who speak non-tonal languages like English. And why would that be? Well, it's because in a tonal language, the pitch you use can completely change a word's meaning. For instance, in Mandarin, the syllable ma can mean mother, hemp, horse, or to scold, all depending on the tone you use. So from the second these kids start learning to talk, their brains are getting this intense training to pay super close attention to absolute pitch. It's like a real-world perfect pitch workout every single day.
So we've got genes and we've got early training. But what about the rest of us? What if you missed that critical window as a kid? Is it just game over? For the longest time, everyone thought the answer was yes. But now, that's starting to change.
I mean, the scientific consensus for decades was pretty clear. If you didn't get perfect pitch as a little kid, you were never going to get it. That door was considered firmly shut.
But here's the twist. Recent studies are totally challenging that old idea. New super intensive training programs are showing that some adults actually can learn perfect pitch. Now, it's not easy, but it's not impossible anymore.
For example, in one pretty groundbreaking study, adults went through this specialized training, and the results were just stunning. They saw a 128% average increase in how accurately they could identify pitches. It really seems like our adult brains might be a lot more flexible than we ever gave them credit for. Okay, so we've talked a lot about the science of how perfect pitch develops, but what's it actually like to have it? Is it really the amazing advantage we all think it is? Well, the answer might surprise you.
A lot of people with perfect pitch talk about something called the key lock effect, because their brain has this incredibly strong absolute connection to a song's original key. Hearing it played in a different key can be, well, really jarring. As one person on Reddit put it, if you hear a song that's supposed to be in one key and it's played in another, it just sounds super wrong.
Another user had this brilliant analogy. They said, relative pitch is tasting the whole cake. Perfect pitch is identifying the ingredients. It's an amazing analytical skill, but you can see how you might sometimes miss the overall flavor of the cake.
And that really gets to the heart of the trade-off. On one hand, yes, absolute pitch is a massive advantage for things like singing perfectly in tune or catching wrong notes. But on the other hand, that constant automatic pitch labeling can actually get in the way of hearing the relationships between the notes, which is what relative pitch is all about, and what you need for things like transposing music on the fly.
So, to wrap it all up, perfect pitch really seems to be a recipe with three essential ingredients. You need some genetic predisposition, you need that early exposure to music, and you need to grow up in a sound world where paying attention to pitch is just fundamentally important.
So in the end, perfect pitch isn't some simple, magical gift someone is just born with. It's this incredibly complex and fascinating dance between our biology, our environment, and crucially, the timing of it all. Which kind of leaves us with one last big question to chew on. Is this rare ability a genuine musical superpower, pushing human hearing to its absolute limits? Or, in a world that mostly runs on relative pitch, is it just a cool, evolutionary leftover from a different time? The answer, just like the ability itself, is anything but simple.